So today we're just filling in the details of example 3.3, and if you remember back to when we did this part of the work in example 3.2, we showed that if we had two sets A and B, and the set A was defined by the elements in a bigger set where the condition P of X was true, and B was defined by the set of elements in a bigger set where Q of X were true, then A being a subset of B was equivalent to P of X implying Q of X. So that's what 3.2 said. In this example, we're just going to show that if we've got the same condition, so in this example we've got some bigger set E, we've got a set A and a set B, the condition P of X is going to define the set of elements that are in A, Q of X is defining the set of elements that are in B, and what we're trying to show here is that if we've got the two sets A and B being equal, then that's equivalent to saying P of X if and only if Q of X. So we set up this kind of table. It's not a truth table because truth tables only have trues and falses, not numbers, but we listed the elements down the side of our big set E, 1, 2, 3 and 4. And I've just written in here, if X is an element of A, well, 1 is and 2 is, 3 and 4 are not. And the X's that are in B, 1 and 2 are, and 3 and 4 are not. So this is defined by our Q of X, and this is defined by our P of X. So let's have a look and see what happens if we look at, this is Q of X implies P of X. So we're starting with our Q and going that way. So when Q's true and P's true, we get a true. When Q's true and P's true, we get true. When Q is false, followed by anything that's always true. So all of those things are true. Going the other way, so we're starting with P and going to Q. So here our P is true and our Q is true. Again, P is Q true and Q is true. And P here is false, so that's true no matter what Q is. So X in B implies X is also in A. Here X is in A implies X is in B. And now we're thinking about P of X if and only if Q of X, so we've got an AND on these two columns, and you'll see that this is true because everything in our two columns is true. So this one's equivalent to saying B is a subset of A, this one is A is a subset of B, and of course when we put an AND between those two, we've got A equals B if we're thinking about this in terms of sets. So that just finishes off the example when we're defining sets or subsets of sets by conditions P of X and Q of X.